Hey guys, we're working on Unit 7 Quadratics Part 2 review. I picked a few of the questions because I think if you can take on the questions that we do here together in the video, then you can do every single one of them. Remember that you can use your green note sheet, which has the flow chart between all three different forms: standard to vertex, vertex back to standard, standard to factored, and factored back to standard. Okay, so take a look. Question number 1, complete the square on each of the quadratic equations and write in vertex form. Then list the vertex using an ordered pair. Now this gives you the formula b over 2 squared, but remember it's on your green sheet, okay? So the first thing we're going to do is we're going to take b over 2 and square it. So negative 5 squared. Remember, it's not times 2, it's negative 5 times negative 5, which gives you a positive 25. Now remember, that number is what fills in the blank. So 10x blank, then plus 13 minus blank. So that's the number that goes in both those blanks, 25 here and negative 25 here. And now we have to factor what goes in those first three terms, what multiplies to 25 and adds to a negative 10. This is key, guys, because a lot of you guys are going to say 5. But remember, it adds to a negative 10. So it could be negative 5 and negative 5, which it is. So we're going to write it as x minus 5 squared, and then just add these two numbers. 13 minus 25 is in negative 12. And that's my vertex form. X minus 5 squared minus 12. And the vertex is going to be a positive 5, because remember, it's always opposite on the inside of the parentheses, and then it's exactly what you see on the outside of the parentheses. Now let's take a look at question number 4. This is just like our quiz. Okay, what form are you given? Vertex form. What is the vertex? Well, 4 comma negative 9, just like what we just talked about. It's opposite on the inside of the parentheses, and then it's exactly what you see on the outside of the parentheses. Now it says convert to standard form. Well, I'm going to rewrite what it means to be squared, which is multiplying something by itself, and since the whole expression, x minus 4, is being squared, that's what I have to multiply by itself. And then I'll use my distributive property. X times x is x squared, x times negative 4 is negative 4x, and then I'll distribute the negative 4. I get another negative 4x, and the negative 4 times negative 4 becomes a positive 16. Don't forget about this minus 9. That's where people are making a lot of mistakes. Now let's just combine some like terms. Negative 4 minus 4 is negative 8x, and then 16 minus 9 is going to be positive 7. Here is my standard form. Now it says, what is the y-intercept? Expressed as an ordered pair. Some of you guys lost a half point because you did not express as an ordered pair. Well, it's always going to be the constant. Remember, a y-intercept always has an x value of 0, and then whatever that constant is, in this case, 7. Next, convert from standard to factored form. We're keeping it in factored form. We're not solving for the x-intercepts until it asks for it in part F. So what are two numbers that multiply to 7 and add to negative 8? Well, multiplying to 7's got to only be 7 and 1, but 7 plus 1 is positive 8, so it's got to be negative 7 and negative 1, which still multiply to a positive 7, but then add to a negative 8. This is factored form. Done. And now it says, what are the x-intercepts? So now we can set x minus 7 and x minus 1 equal to 0. Plus 7 plus 7 plus 1 plus 1. So it says express them as ordered pairs. So we have positive 1 and positive 7. So I'll write that as 7 comma 0 and 1 comma 0. Notice that an x-intercept has a y value of 0. Now it says graph the critical points, x-intercepts, y-intercept, and vertex. Let me just quickly write this down. I got my vertex is 4, negative 9. Got my y-intercept is 0, 7. And I got my x-intercepts is 7, 0, and 1, 0. Sorry about that, I went to the other page, but let's try this out. Let me get a quick sec. Okay, so let's graph the next page. Take a look up at the top. Let's graph our critical points. We got 4, negative 9, so I'm going to go to the right 4, down 9, plot that point. And then I'm going to go, my y-intercept is 0, 7, way up here. My x-intercept's at positive 1 to the right 1 and to the right 7. Remember, it does open up because the lead coefficient is positive, so then I'm just going to graph my U shape right through those coordinates. And look, it makes a perfect symmetrical U. If you want to add in the x of symmetry, you could draw a vertical line right through the vertex, which would be x equals whatever that x value of the vertex is, which is 4. Okay, let's go down to question number 6. Graph the following quadratic using the x of symmetry method. Well, now we can actually see exactly what it looks like. Well, the x of symmetry is always the formula opposite of b over 2a. So if you want to label your a, your b, and your c, that can help you out. So it's x equals the opposite of 6 all over 2 times 1. So negative 6 over 2, which simplifies to negative 3. Well, that's my x of symmetry. X equals negative 3. It's always a vertical line, okay? Now to find y, you just take it and plug it in. Negative 3 quantity squared plus 6 times negative 3 plus 5. Well, negative 3 times negative 3 is positive 9. Positive 6 times negative 3 is negative 18, and then plus 5. Well, 9 minus 18 is negative 9, plus 5 is a negative 4. So my x was the negative 3 that you found in the beginning, and then my y is this negative 4 that you just calculated. Okay? Now, this 1, 3, 5 method is just for plotting extra points, but we can just use other points that we know. If I want to plot negative 3, negative 4, which is down here, I could plot my x-intercept. If you want to factor it, what multiplies to 5 and adds to 6? Well, 5 and 1. And then I get x equals negative 5, x equals negative 1, so I could plot that. Okay, I could also find the y-intercept would be 0, 5, because we already got standard form, which is way up here. And then we got our u-shape. Remember to graph that axis of symmetry, which is a vertical line. Sorry, my lines are getting bad. Right through at x equals negative 3. Okay, last question, the baseball question, the word problem. A baseball is thrown into the air. The height of the ball in feet, which is the y value, has a quadratic relationship with time, which is the x value, in seconds. The ball's path can be modeled by the following equations. Okay, these are equivalent equations. Well, first we have standard form. So we could find y-intercept, we could find initial height, we could find is opening up or down. And then we have factored form, so we can find x-intercepts. When does it hit the ground? Okay, but we don't have vertex form, so we can't really find the vertex unless, remember that we could use our axis of symmetry method out of standard form. So it says, what is the initial height of the ball? Well, that's easy, that's our y-intercept. So we can just look right here to our standard form. 0, 6. And then it says express as an ordered pair and label the critical point on the graph. Go down here and label it right here at x 0, 6. Okay, let's go back up to question 2. When will the ball reach its max? So we need the vertex. Okay, so let's use our opposite of b over 2a. Opposite of 20 all over 2 times a, which is negative 16. So I get negative 20 over negative 32. Simplify that on my calculator. I get 0.625. And it says when. Okay, so when is the input? It's an x value. So that's actually the answer right here in 0.625 seconds. And then part C says take your answer and determine the maximum height, because we know when it's going to reach the maximum height, but now we got to figure out how high is that. Okay, so let's take our 0.625 and plug it in for x. And remember, this is just a simple calculation on your calculator. Plug it all in, let's see what it takes. So I have my calculator, I'm going to plug negative 16, open parentheses, 0.625 quantity squared, plus 20, open parentheses, 0.625, plus 6. And it comes out to 6.25. Okay, remember that's an output, that's the height, so that's talking about feet. My mistake, that came out to 13 or 12.25. Made a little mistake on my calculator. Okay. Now label that critical point. Well, that's tricky because it's 0.625, comma 12.25. So we got to figure out where that goes. 0.625 is between 0 and 1. Okay, and then 12.25 is way up here, so it's going to be somewhere above the 12. After how much time does the ball hit the ground? Also express as orders pairs and label the critical points. Well, if we're trying to use standard form, we could do quadratic form. Well, that's a lot of work, but we have factored form. So let's just set both of our factors equal to 0. That's the height of the ground, so let's set them equal to 0. Let's see what happens. Subtract 1, so I get 4x equals negative 1, and then divide by 4, so I get negative 1/4. Well, at negative 1/4 seconds, that doesn't make sense. Let's talk about the other one. Subtract 6, negative 4x equals negative 6, divide by negative 4, and we get 1.5. That makes sense. It's a positive number. Around 1.5 seconds, we get our other x-intercept. So let's plot that right around here. Okay, so we have a downward facing u. We have our vertex right there. Now, obviously, if you were to think about what a real-world problem would look like, it would stop right here. It might bounce another time or whatever. But that's what the graph's going to look like. Okay, guys, good luck.